All right, it's 10 o'clock. I'm glad you two are here on time. Thank you. This is Allison. She is another teacher here at Options, and she's actually my mentor, and she is my mentor in fully finishing my teaching credential. So she's going to observe today, and she'll probably be back throughout, next semester too in the spring. So everyone say hi to Allison and be nice.
Hey everyone. Thanks for letting me join your class today.
Good morning, Maria. Good morning, Hunter. All right.
That is a very large cat. I also have a very large cat, so I love very large cats.
I love it. It was good to meet you today, Hunter, and see you. Get to see you in person because I think this
Yeah,
whole time I've only known you as the very large cat, which is
right.
hilarious. Yeah. All right, everybody, get your paper. Let's see. I need to share, and we'll get going. Okay. Let's see here. Okay, get your paper because we're gonna have a brief notes. We're gonna finish up this section on comparing data sets, which we started yesterday. I've got an activity for us, and then if we have time, we can jump into the mastery test together. And if not, that'll be our assignment for the weekend for the holiday. Good morning, Braden. Thought I saw Braden join. Oh, connection. Okay. So, announcements, everybody. Happy Thanksgiving. No class or teacher meetings next week. There's our turkey. I hope you all have a good weekend and a good holiday week next week. I'm looking forward to it, to cooking a turkey. So, class with me and with your regular teachers will resume on Monday, the 29th. That's not this Monday, that's 2 Mondays from now. Unit 5 that we're in now, everything we've been doing with statistics. So, like no parabolas, no quadratics, all the statistics work we've been doing will be complete after Thanksgiving. We have one lesson left and we'll need to review and then we'll take our test. If you are behind on past units like unit 3 or 4 or 5, you can still finish. You can still catch up. Lessons are being put onto YouTube, and then you've got the tutorials available as an extra instruction if you need to refresh on that stuff before taking your mastery tests. And then, like always, just remember I'm offering office hour on Tuesdays at 3 o'clock. And I'm not getting a lot of you joining. If you are struggling, if you have questions, if you feel like you need help one on one, I want you to join me on Tuesdays at 3 o'clock. Of course, not next week, though. And then we also have Brandon, who I'm sure a lot of you know or have heard of. He's our math intervention specialist. Here's his email. So you can make other appointments with Brandon throughout the week. And he offers Fridays at 10 o'clock, 10 a.m. for a full 2 hours just for you guys, if you want to take advantage of that help as well. So you've got me and you've got Brandon to help catch up on the stuff if you need it. Now, but with the reminder that next week there's no meetings for Thanksgiving. Any questions, concerns? No? Braden, did you get joined finally or no? Are you here, Braden?
Yeah, I don't know why I kept like I would join and then it kicked me out, join, kick me out. But I'm
No,
in now.
no worries. I'm glad you're here. And by the way, I heard a little bit of that. I'm sorry to eavesdrop, but I heard you talking to Shannon, and I'm super happy for you. To
Oh yeah, thank you.
Good for
Yeah,
you.
I'm glad I'm in there.
You're doing good, man. All right, so no questions. Let's jump into comparing data sets day 2. Make sure you're taking notes. I want you to have these tools for later. Okay, so let's start with a warm up. We've been working all week with sets of data and getting a lot of practice finding the median, finding the 5-number summary. So I want you all to try this out, and then when you are finished, or if you get even just a partial answer, just tell me in the chat or tell me verbally that you've got either the full answer or even just part of it that you're ready to share. 5-number summary for this data set. So we're going to do this for maybe 1.5 minutes. Remember, the first step is to put them in ascending order. And then find the middle value. Let's do a quick check-in. Did we get them rearranged in ascending least to greatest order? Can anyone give me some confirmation that we've got them rearranged yet?
Yeah, I do.
Aaron? Awesome. Anyone else? All right, I'll give you another moment. Really? Just Aaron? Aaron, high five to you. Can anyone else tell me they've got them rearranged yet in ascending order?
You mean from like least to greatest?
Exactly. Yes, sir. Least to greatest.
So wouldn't it be 4, 5, 5, 7, 7, 9, 10, 11, 13, 14, 18. Oh no, 14, 17, 18, 20.
All right, Braden. Well, you got it. That's what I got. Aaron, let me know if that's what you got as well. And Maria, I appreciate you giving me the feedback. So let me write down what Braden said. Let's see here. 4, 5, 5, 7, 9, 10, and 11, 13, 14, 17, 18, 20. Okay, cool. Double check my work. I might have made a mistake, folks. Double check. Aaron, did you find the median? Can you share that with me?
10.5.
Very good. Now, this could be tricky. We've talked about this. We've only seen a few examples as a group, though. Where'd that 10.5 come from? She had to count in from the outsides. So if I was doing this on paper, I would just straight up cross them out as I go. I'm going to just underline them. So counting in from the outsides, one at a time on the left and on the right. And then we get to hopefully the middle value, right? And that's our median. But Aaron found this. She got to 2 middle numbers. Uh-oh. So how do we rectify this? How do we deal with that? We find the value right in the middle of those by finding the mean. So we add them, 10 plus 11, divide by 2. And when you do that, we get 21 over 2, 10 and a half. So I'm going to add that in there. And we call that Q2, or we can call it the median, same thing. Okay. So we found the very middle of our data set. And sometimes that does mean kind of finding the middle of 2 values like we did here. Okay, and then we need to find Q1, Q3, and the minimum and the maximum. So to find Q1, here comes Delaney, hang on. To find Q1, we're going to repeat the same process, but just with the left numbers, the lower values. So 4, 9, 5, 7, and then what's left in the middle, folks? That 5, the second 5. So that's our Q1. Same thing on the right. What is Q3? Can anyone tell me what Q3 is? What's the middle value of just the high set of numbers? Something in the chat. What is this? 17. Maria, thank you so much. So yeah, we count in from the 13 and the 20. We're kind of disregarding whatever we found for Q2. So we don't use that 11 or the 10.5. We're just looking at the 13 up, counting inwards. And like Maria, I got Q2. And then minimum and maximum, those are our easy ones. That's just the lowest number, 4, and the highest number, 20. Max. And there's the 5-number summary. These 5 numbers are what we would use to make our box and whisker plot. Any questions, concerns? Please. Okay. All right. Well, let's jump into the rest of this lesson and see what that entails. Okay, so recall with me that quartiles, the Q1, Q2, Q3, are cutting our data into 25% chunks. Quartiles are those Q numbers that we just found in the last example. And when we find them, we're kind of dividing up, cutting up our data into 25% chunks. So if we have it graphed out in a box and whisker plot like this, we see this stretch of the first whisker is 25% of the numbers, of the data, of the list. So is this, another 25%. The third grouping at 25, and then the last grouping is the final whisker. So what's really useful about this is that we've got our data, we have a visual for it with our box and whisker. And this week we've been looking at that interquartile range. The interquartile range, you know, is the Q3 minus the Q1 number. That's giving us the spread of the middle 50%. Like the middle 50%'s worth of the data values. It's kind of like disregarding the low end down here and the high end. And we're just kind of focused on what are the numbers that are grouped around our median because they're closer to it. So that's what makes them a little more important. That's why we bother finding the interquartile range, because it's kind of focusing in on that middle 50%. this is going to come into play. So I just wanted to kind of give us a reminder. Any questions, concerns? Okay. If you do, just jump in. Please do. So also recall from yesterday, we learned when to choose the mean or the median to represent the center of the data. We know how to find the mean and the median. Median is the same thing as that middle value, Q2. The mean is where we add them all up and divide by the number of numbers. So we saw yesterday, if the mean is less than the median, then that gives us a right skewed data. Oh, shoot, my bad. Bad notes. This would be left skewed data. The mean is less than the median, left skewed. And the overall shape of our data would look like this, with a tail on the left. The mean follows the tail. Remember that. The mean is following the tail. So if the median is kind of near the hump, the high end of the data, then the mean is somewhere over here. It's smaller. It's less than that. It's following the tail, and it's giving us that left skew. And then likewise, if the mean is bigger or greater, then we're getting the exact opposite. We're getting right skewed data with the tail going towards the right. So the median is somewhere in that closer to the hump, the high part. The mean is chasing that the tail of the data this direction towards the right. Right skewed data. So we just take our list, we calculate the mean, calculate the median like we just did in that example, and compare the numbers. And if the mean is bigger, we know it's right skewed, and we would want to choose the median in both these cases to represent the center. We choose the mean when we get our nice, happy, symmetrical data, where it's the same on the left as on the right, our normal or symmetrical. So today, we're going to look at when to, we're going to look at the spread of the data instead of looking for a center. So instead of deciding, do I want the mean or the median to represent it, do I want to choose this option for representing the spread or another option? So we've got a choice to make to determine the measure of spread for the data set. For left and right skewed data with tails that's not symmetrical, we want to choose that interquartile range because it's saying, okay, our data might be skewed one direction or another, but if we know the interquartile range, we're basically picking that chunk of data right in the middle, that middle 50%. It's kind of like saying we're going to disregard the weird low-end outliers on the left or right. For normally distributed data, the perfect ones where it's right in the center and it's the same on the left and right, for this case, we want to choose what's called the standard deviation. This is what's going to be new for today. Brand new. I'll wait on this page for a moment if anyone's writing, and then we're going to look at standard deviation. Any questions, concerns so far?
Not for me.
Thanks, Braden. Okay, let's go. So standard deviation, it's a measure, so it's a number. I'm going to add that in here, of how spread out the data is from the mean. So when we work with standard deviation, we'll be given a number. And it's describing, on average, how spread out that data is from the mean. I want to show you some examples. Now on the left, I'm going to draw really spread out data, and that would represent having a higher standard deviation number. So let's say we had some example data and we mapped them on a number line like we've been doing this week. Let's say our mean is right here in the center of my picture, and our datas look something like this. Okay, not much to write home about. It's just kind of spread out. What if we had a second set next to that with more tightly packed data? It could even have the same number of datas. Let's see, I did 1, 2, 3, 4, 5, 6, 7, 8, 9. So the mean is here in the center. So same mean, but they're closer together on average, right? On average, the set on the left is more spread out, more space, more air in between those values. And on the right, they're more condensed, more tightly packed. So on the left, when it's more spread out, that would correspond to having a higher standard deviation number. So for example here, let's say that this might have a standard deviation of, we'll say, 2. And on the right, when they're more tightly packed, when the numbers are closer together, this would be a lower standard deviation number because on average, they're closer to the mean. So the distance of each one of these data points is smaller away from that mean. And that corresponds to lower standard deviation number. Maybe this is a number of 1.5, slightly smaller. And that's reflected if we mapped them out visually on a graph, or if we're given the standard deviation number, it's telling us ahead of time, the smaller the number, the closer together the numbers are, the smaller the standard deviation number. We're going to look at some more concrete examples in a moment. All right, I'm going to wait another 10 seconds. And if anyone needs more time, just let me know. Okay. So for a normal distribution, try to make this nice and smooth. There we go. Symmetrical on both sides. No concentration on the left or right. Right in the middle is our mean. And when we're looking at standard deviation, they correspond to some useful and repeated patterns. So when we have normal, standard, symmetric data like this, one standard deviation away on both sides. Let me change my color for this. That might be helpful. Sorry, one moment. Okay, so one standard deviation away on both sides. So it's like taking the mean and adding the standard deviation number and subtracting it to get this spread right here. This represents 68% of the data. Meaning 68% of all the numbers in your list are packed into that zone. 2 standard deviations away, the yellow, 2 standard deviations away, so that same distance away, but 2 on the right and 2 on the left from the mean. This space represents even more of your data, 95%. So 95% of the numbers from the list would fall into that yellow range away from the mean. Notice that we're like getting farther away from the mean and there's fewer and fewer datas. That's why the hill has that shape. It's getting smaller and smaller. And if we go the third third step away, let's do orange. Hopefully that's not too conflicting. So the third step away here and here. And below I'll put the arrow. So this whole spread, 3 standard deviations on both sides, is 99.7%. Let me add this in. I'm sorry, I should have labeled these. So this is 3 standard deviations from the mean. And then yellow is 2 standard deviations away from the mean on both sides. And then having 1 away on both sides in purple, 68%. Okay, any questions so far? I realize we haven't worked with it yet. We're just talking about it. Any questions?
I know. I'm just kind of writing it down, trying to understand.
Totally. Now, I want to be honest with you, folks. Finding standard deviation by hand is a great skill, but it is really, really complicated. And it honestly just varies from high school to high school. Most high schools don't even teach it in a Math 2 class, and I wasn't going to either. I was going to introduce this idea to you of using standard deviation when we're given it. So that's the level that I want you to be able to be comfortable with this in the end, is to be able to have an idea of what it means and to be able to use it if it's given to us, but not to compute it from scratch. What it represents is the average distance away all the points are from the mean in the middle. So like I said, I'm going to go back here. So like this example, I want you to know that the higher standard deviation numbers, like our example on the left, standard deviation of 2, that means the data is more spread out than a set with a lower standard deviation number. So I also want you to think of the word consistent. So the data is a little more consistent when we have a lower number. More consistent. Let's try a practice problem using the idea of standard deviation. Okay. A company is analyzing monthly data for the number of cars sold at 3 of its dealerships. Below, there's our 3 dealerships, and there's some data from each one. It calculated the mean and the standard deviation of the data. Now, they're not giving us the whole list of cars sold, right, for dealership A, B, or C. That list exists somewhere, but what we've been given is just the mean number of cars sold. So, for instance, dealership A looks like they sold on average 45 cars per month. Dealership B sold 48 cars per month, and C sold 50 cars per month. Oh, Laysia's here. All right. And then also the SD, the standard deviation, is written there too. So what that means is, let's look at dealership A together, 2.2. So on average, that means the different numbers of cars sold per month for dealership A is about 2.2 away. So for instance, if the mean number of cars sold all year was 45 for dealership A, that means that all the other numbers of the cars sold for that month were about 2.2 cars away from 45. So maybe the next month was 45 plus 2.2. That is 47.2. Now, 0.2 cars doesn't actually make sense, but from a statistical point of view, we end up with some decimals. So maybe that means they sold 47 or 48, right, in a real world scenario. a different month. Okay, so here's some questions to try to use this data. One at a time here. The top one, the dealership that's the most consistent in selling cars. So how can we tell that from what we've been given? The most consistent in selling cars will be the lowest standard deviation that we can have access to. We'll add that in here. Lowest standard deviation. So looking at the data, it looks like dealership A had the lowest standard deviation. So that means dealership A was more consistent than the other two dealers. Let's look at the second one. The dealership with the highest average number of cars sold. Highest average? What's another word for average that we've been using this week? Does anyone remember? Starts with an M. Okay. No? Mean. So this one's just asking us which one has the highest mean. So we can scan through our data and find, okay, dealership C sold on average 50 cars per month, which is more than the other two dealers. Let's look at those last two. The dealership for which 68% of the data lies between 44.2 and 51.8. Because they're mentioning that 68% of the data, that means we're going to be using standard deviation somehow, some way. So that's our clue right there, that they're referencing this kind of bizarre sounding percentage, 68%. But we know that when we have a normal distribution, 68% of our numbers fall between the one standard deviation away from the mean on both sides. So I'm going to move screens, but I've got the same information up. So follow with me. So I want to just kind of show a picture of what's going on here. Let's look at dealership A. And if I put this into a normal curve, the data that they gave us, the mean is right in the middle, the highest part, that's 45. And one standard deviation away on the right and on the left represents 68% of our numbers. So what is one standard deviation away on the left and right, on the low end and high end from 45? So 45 plus 2.2 is 47.2. And the low end is 45 minus 2.2, the standard deviation. What is that? 42.8. So 68% of dealership A's data lies between those two values, 42.8, 47.2. So let's try it again for dealership B. Right in the middle is the mean for dealer B is 48 this time. It's different numbers. And it's got a different standard deviation, 3.8. So subtract 3.8 and add 3.8 to 48 to see where 68% of their numbers lie. So adding it does give us 51.8. That's promising because that's that's the high end of that third question. And if we subtract it, 48 minus 3.8, 44.2. Cool. So that means it's dealership B for this one. We didn't check C, but we did find that this matches up for dealer B. Now for the last question, they ask about 95% of the data. So we know that also corresponds to this idea of standard deviations away from the mean. So check and see for me. Try this one on your own. Check dealer A, dealer B, and dealer C. Adding 2 standard deviations away from its appropriate mean. I better change my color. Not sure if you can see that. So the mean is the middle, 45. We've already figured it out for adding 1 standard deviation away. But we've got to do 2 away to check that 95%. So add and subtract another standard deviation, 2.2, from those values to find that larger spread of 95%. Did anyone find that for A or a part of it? Maybe I should show you this since this is new and probably kind of weird. What I mean is we're looking for 2 standard deviations away from 45. And for dealer A, their standard deviation number is 2.2. So 2.2 plus 45 is this 47.2. We got to add it again, though, to get another 2.2 away. So I'm like adding 2.2 here twice. So 47.2 plus 2.2 gets us 49.4. Okay, and then we got to do it again on the left. So we're subtracting it and subtracting it again. So 42.8 minus 2.2 is 40.6. Okay, so what is this telling us? For dealership A, 95% of the values fall between 40.6 and 49.4. Doesn't match up with what they're asking us for that question. So what we've done is ruled out, eliminated A as an option. So we've got to try that again for dealer B and dealer C. I'm going to jump to C because we haven't even looked at it yet. So dealer C here, make your normal distribution. The mean right in the middle is 50 for dealer C. 2 standard deviations away on the left and on the right will be 95% of the data. So that means we've got to add 2.4 twice on the right and then subtract it twice on the left. To find out what those values are. So 50 plus 2.4 plus 2.4 is 54.8. And then 50 minus 2.4 minus 2.4 is 45.2. So that's 95% of dealer C's values. They fall between 45.2, 54.8. So when we're dealing with these kinds of questions, if you see 68% or 95%, or the third option was 99.7%, which sounds really weird. If you see those pop up, we should be going straight to, okay, this is a standard deviation question. So we're going to need to use, I'm going to move back a screen. We're going to need to have this. Uh-oh. We're going to need to have this picture ready to go. So we know how many standard deviations away we're dealing with. 68, 1 standard, 95 is 2, 99.7 is 3. I'm going to go back to that other page. I better go grab my charger. I didn't realize I was short on battery. Okay, things got real quiet. Are there any questions right now? How about we do some thumbs? Can I see your thumbs to see where you fall right now with what you've seen so far today? Keegan, okay, thanks Keegan, appreciate that. And Delaney, thank you. You feeling okay on this idea of standard deviation? How about the rest of you? Maria, thank you for your feedback. Leja, I see that. Manaya, Hunter, Aaron, Braden.
I get it. I understand.
Okay, thank you.
Hi.
I see you, Braden. Appreciate that. Okay, so here's what I want to do. How many of us are in class right now? All right, we've got 8 of us. Perfect. So I'm going to put you all into a group of 2. Okay, so I'm going to open up 4 different rooms and put you into groups of 2. Before I do that, though, I want you to go to Gmail. Here, want to look at my screen again. Get all this stuff out the way. I want you to go to your OFI Gmail. I've shared this Jamboard with everybody. So you should see it probably at the top of your Gmail email list. Open up that email, click on the link, follow the link to today's Jamboard. I'm going to put you into groups of 2 since that works out. I want you to try working on a page of the Jamboard that I'm going to assign to you. Do your best, work with your partner, and I'm going to come around and visit with each of you to give feedback and see how it's going, okay? And then if we have time, we'll rotate and try a different room. So go ahead and access the Jamboard for me now and open up your, do that. And I'm going to open up some rooms, but let's see, how am I going to assign these at the, one moment. Okay, so the room number will tell you which page to go to. Let's do that. So let's have Braden and Aaron go to room 1. Let's have Delaney and Leja. Leja, I know you got here a little late, so I'm going to have you work with Delaney on page 2. Let's have Hunter and Keegan together on room 3, and then Maria and Manaya together on page 4. Room 4, page 4. All right, so go to your breakout room, start your problem on the Jamboard. I'll be right back. I'm sorry I have to step out and grab my charger. And then I'm going to come around and visit you in your rooms. All right, very good. People are in 7 total. Braden, great. Okay, yes. All right, folks, I'm back. So, sorry about having to leave.
Hey, Josiah.
Hey, Braden, Aaron.
So, just a quick thing.
Yes.
So the 2 days that I wasn't here,
Yeah.
I
Go ahead.
Did you go out?
Braden, can you hear me?
He was kind of telling me, he was like,
remember
he didn't.
I did this. I think
Oh yeah, there you go.
I did this in like 9th grade or 8th grade. One of those. I remember. So it was like slight, but yeah, I don't fully understand.
Yeah, totally. This is a totally different unit, right? It's a step away from what we were doing in the first 4 units.
Yeah.
So that's why I actually paired you with Aaron. So that way, hopefully together, it would help a little bit more. Just to try to get some exposure to this. I'm not expecting you to like totally fully be able to do this on your own right now, this second. I do want you to check out, the lessons from Monday, Tuesday, Wednesday this week, and try to refamiliarize yourself and practice it this weekend and next week, and then we'll review more when we come back from Thanksgiving break. I will say today I think is probably the pinnacle so far, like the hardest that we've like dealt with this week too. So it is what it is. You came back at the hardest day. What I'm trying to say is do your best, don't give up. And I think with some catching up and some practice, I think you can definitely get this. Are you still there?
Yeah, I'm still here. Sorry, I couldn't get my mic off mute.
That's okay. Okay, well, you two, let's see. I wanted you guys to try the first page. Are you both on page 1 of the Jamboard?
Yeah, we're page 1.
Okay, so this one is, here, let me move the picture up again. Sorry about that.
Oh, that might have been me. I think I moved it.
It's all good. Either way, we have to determine the measure of center and the measure of spread for each set. So in the gray box, those are our choices. So for center, just a reminder, we're going to pick either median or mean. Median or mean is our measure of center. So this is kind of like yesterday's work. We don't need standard deviation to figure out the mean or the median, or which one we would want to pick. Now, I went over this briefly today just as a quick reminder, but basically, if the data is normal, if it's symmetric, like class A looks like it is, versus if it's got a tail like class B, that tells us, do we want to choose median or mean?
Okay, that makes sense.
And then to decide, do I want to choose the standard deviation or the interquartile range? That's also the shape of the data. So if it's a standard, normal looking shape like we see in class A, then we want to use the new thing from today, standard deviation.
Oh.
If we have skewed data, that's when we use the interquartile range. Why is it that way? Because remember, with skewed data, the mean is being pulled towards that tail. So measuring, we don't really even use standard deviation or talk about it for really skewed data like we see in class B, because right around the mean isn't most of the data. Most of our data is packed over on the right side here. Sorry. Let me show you with a pointer. Here we go. So on class B, see where the tall towers are in that data on that bar chart? That's where
Yeah.
most of the data is, right? It's like all packed over there with a little bit in the 70 to 80 and then a little bit even less on those lower towers. So that's why we choose the interquartile range here, because more of our data will be, or more representative, I should say, is kind of here instead of, and that's where the mean will be, somewhere over in this space. So the interquartile range will do a better job of kind of grabbing a representation of that spread. And if we choose the mean, which is closer towards that 70, that's less helpful. So measure of so basically, if we can see the shape of our data and it's symmetric like class A, then we're going to choose mean and standard deviation. If we have skewed data like in class B, with that looks more like a slope, then we want to use interquartile range and median for center and for spread. And I'll tell you what, it's almost 11. So what I'd like you guys to do is move on to page 2, see what that looks like, and just give it a shot. These are from the practice. So if you want to see them again later and try them out and get some like answers and feedback in it, try the practice later today for this comparing data sets, okay?
Okay.
Okay. So go ahead and move on. I'm going to check in with the other groups, and then I'm going to pull everyone back at just right before 11 to kind of say goodbye.
Okay.
Okay. Thanks, man. Thanks, Aaron.
All right.
All right. Doug is analyzing the daily profits.
Okay. Sorry about that. Hey, Allison. Hey, Delaney.
Hey, hi Delaney.
Delaney, you still there?
Hello.
Awesome. I'm sorry you're all by yourself. I had assigned you with somebody. I didn't write it down, and it looks like they left the call altogether.
Yeah, it was Leja. She said that she didn't have her Wi-Fi was going really slow,
Totally.
so she said that she couldn't even open the document.
So, Delaney, you said you were feeling okay on this so far. Did you make any headway with page 2 on the Jamboard?
Yeah, so far I've just been on question 1, which location
Totally.
has the highest average daily profit. And so far I've gotten B.
B. Yeah. Why'd you choose B? I agree with you. Why'd you pick B?
I got B because the number, the 6,296, is the biggest out of all of them.
Very good. Very good. Highest mean and highest average is just a code word for mean. It's really hard for me to write well on this Jamboard. There we go. Mean. Things get a little crazier when we have to start looking at where does the data fall? Where does 95% of the data fall, or 68%? But that's our clue that we're going to be using the standard deviation stuff from today. So let's look at the second one together. It says 95%. So what we need to do to answer this question is look at each set. We'll have to do one at a time, A, B, and C. The mean number would be right in the middle. So looking at A, set A, location A, that's the 6127.85. That's a lot to write out here, but that would be the very middle of our data, basically. Then, to figure out this 95% of the data falling between here and here, we need to add the standard deviation number, which is 413.51, twice to this mean of 6127. Let me do that on my calculator. You can do it on your phone or calculator. Ugh, I made a mistake twice, and now I have to start over twice. 6127.85 plus 413.51. Okay, then I'm just going to do plus 413.51. Okay, so for the high end, Delaney, I got, and that's 2 standard deviations away because I added it twice. I got 6954.87. Okay,
I got that too.
awesome. And I think we can go ahead and stop checking A just because it doesn't match up with what we're hoping it would be. Looking back at the question, 6852. So then I would say, okay, it's not A because it didn't match up with this number here. So we can move on and try the same process for B. But B has different numbers, right? So we'll use those values, that mean, and then that standard deviation. And if that works, awesome. That means it's location B. If it doesn't work, we've got to check location C and make sure that one adds up. Any questions so far?
No, not so far.
Okay. It's almost 11. So unfortunately, I need to pull everyone back to the main room and just give you your assignment to try for this weekend, okay? Thanks for working with me, Delaney.
Thank you.
Thank you.
Thank you.
Bye.
Bye. Well, just 1 second, guys. Sorry. Breakout rooms. Close all rooms. Okay. Okay, everybody. Let's see. Thank you for trying that. I'm sorry we didn't have enough time. I didn't meet with the last 2 groups. Is everybody back? Yes. So the problems that I have on that Jamboard, you still have access to. So feel free to just look at those and try them. They're also in the practice for this lesson in Edmentum. So our homework for the weekend, for today and for the weekend, is to finish or at least attempt the mastery test called Comparing Data Sets. Now we've seen everything that we need to conquer that mastery test. It covers stuff from yesterday and from today. And the questions in it will look just like the ones on today's Jamboard. So if there's, it's almost 11, so I got to let everybody go. So have a wonderful weekend, a wonderful Thanksgiving. Hopefully it's happy and safe. And I will see you on the 29th when we come back after break.
Okay. Have a good weekend.
You too, Braden. Thank you.
All right, bye.
Bye, Aaron. Thanks, Keegan. Bye. Thanks, Maria. Delaney, have a good weekend.
Happy Thanksgiving.
Happy Thanksgiving to you.
How you feeling?
I'm okay.
Big deep breath. Big deep breath.
It was okay. I practiced my lesson last night and this morning, and I didn't think that it would. There's planning changes I would have made to like the first half, and then the computer. I've never once had my battery die while doing my lesson, so I don't know what happened there. Of course, it happened today, and
Of course. Yeah,
and then
always.
obviously timing wise wasn't perfect because and planning my own timeout because I didn't make it to everybody for some feedback.
Okay.
I talked to
Yeah.
the first group. I wanted to bring you in, but then I don't remember the timing. You were gone. You came back, and then I brought you into the second one with Delaney.
Yeah. That was good. Well, that was good.
So
All right.
I mean, I don't know. I'd give myself at least a 65% or maybe a 69 or a 70 if I was being generous.
Oh.
But
Stuff. Yeah, you had some really good content, and you had some ways to engage them. I think you're right. Like there were structurally some things that
Yeah.
could have happened first, um, and that's all a matter of hindsight. But yeah, we'll debrief at 3, and we'll go through it in more detail.
Awesome.
Yeah, you did fine, Josiah. No stress.
Thank you.
Seriously, no stress.
I got to start math 1. There's a couple.
Okay.
Let's see what's going on here. Oops.
All right. Yeah, I'll get out of your hair. Good luck with math 1.
Okay. Thanks, Allison.
Okay, you're welcome. Bye.
See you later. Bye.
Hi, teacher.
Victor, hello. Thank you for waiting.
I have a question. For my for my units from this month. I mean,